All right, number 6, solve then graph the following inequality in a number line. So I have variables on both sides. The first thing I would do is get rid of the fraction to make my life a little easier. So on this one, I would just take the denominator of 7 and multiply it with everything. So 7 times 4 is 28n minus 7 times 3, which is 21. Bring down your less than or equal to. 7 times 3n is 21n, but it's over 7. And then plus 2 times 7, which is 14. Reduce 21n over 7, you're going to get 28n minus 21 less than or equal to 3n plus 14, because 21 divided by 7 is 3. Now we don't have any fractions. So now what I would do is take 3 and subtract it from 28n, which would give me 25n minus 21 is less than or equal to 14. I then would add 21 to both sides, which would give me 25n is less than or equal to 35. And then divide both sides by 25. So n is less than or equal to 35 over 25, but we must reduce, of course, of course, of course. They're both divisible by 5. So it would be n is less than or equal to 7/5. So again, to graph, we draw our number line. I would put 0 for sure, and 7/5 is positive, and it is less than, or I'm sorry, it's a closed dot because it's less than or equal to. So shade in your dot, and then because it's less than, we're going to shade everything to the right. It's left, sorry, left. One thing to make mention is when dealing with inequalities that are simple like this, where there's only one sign, ideally try and keep the variable on the left. Ideally keep the variable on the left. So the last two, the variable are on the left. So please try and maintain that. For number 7, we got another inequality, but now it's a compound inequality where we have to isolate the variable in the middle. So I will show my steps for this one because I don't want you all to make a mistake and forget a step. So to isolate the variable, I first would have to subtract 5, but I'm subtracting 5 from everything. Please be mindful of that. You must subtract 5 from everything, not just itself and 20 or itself and 4, everything. And when I subtract 5 from everything, I would have negative 9 is less than 3f, which is less than 15. And then continue until your variable is isolated. So now I would divide by 3 everywhere. And now you would get a negative 3 is less than f, which is less than 5. So this is your solution. And now we're going to graph it on a number line. So we need a negative 3, we got a 0, we have 5. So negative 3 and 5 will both have open dots because there's no equal bar. And since f is in the middle, we shade in the middle. Your variable in the middle, you shade in the middle. For number 8, we have another inequality, but it's a compound inequality, an OR inequality. So when that word or is there, that doesn't mean you have a choice of which one to solve. You have to solve both. Sorry, folks, but you do. For the one on the left, I would add 2 to both sides. Okay, but don't go into this other one. All right, keep them separate. So when I add 2 to both sides, I would have 5v is less than negative 35. I then must divide both sides by 5. So I would have v is less than negative 7. So that's one of the solutions. On the other side, I would have to subtract 3 first. So I would have negative 6v is less than or equal to negative 18. Notice I carried down the or in between, so can't forget that. Now I divide by negative 6. So that would give me v is greater than or equal to, because why? I'm dividing by a negative. So my sign must change directions. So negative 18 divided by negative 6 is a positive 3. So bring down your or. So this is our solution. V is less than negative 7, or V is greater than or equal to 3. So let's draw our number line. We need negative 7, we need 0, we need 3. So for negative 7, it's going to be an open dot because there's no equal to bar. And since it's less than negative 7, we shade everything to the left. For 3v is greater than or equal to 3, we need a closed dot on 3 because of the equal to bar. And we're going to shade everything to the right. Number 9, we have an absolute value inequality. So again, it would be helpful to you anytime you have absolute values is to draw a box around it. And ask yourself first and foremost, is the box alone? On this particular case, the answer is no, because I have a 2 trying to multiply the box, and I have a 5 trying to take stuff out of the box or away from the box. So first things I would do in this scenario is to add 5 to both sides. So that would leave me with, let me change screens for more space. It would be 2 times absolute value. I'm sorry, I don't remember what the question was. 3x plus 1 is greater than or equal to 11. There we go. So if I had 11 and I added 5 to it, that means it's 16. All right, there we go. We're good now. But again, we still got to take care of getting rid of the 2. So I would divide both sides by 2. which would give me the absolute value of 3x plus 1 is greater than or equal to 8. So remember, this is a greater problem, so it is an or inequality, which means the two tracks, because there's always two tracks when you have the box. So the two tracks are as follows. Track 1 less than when it's or. So 3x plus 1 is less than negative 8. So less than the negative, that's track 1. And then track 2 is the greater than track. So that would be 3x plus 1 is greater than the positive version. Okay? So again, you have two tracks. I tend to put the opposite track on the left this time and the original track on the right. And I'm sorry, I forgot my equal to bars. Let's put them there. Now we solve each one. And don't forget the word or. I would first subtract 1 from both sides, which gives me 3x is less than or equal to negative 9. Then divide by 3, so x is less than or equal to negative 3. On the right inequality, subtract 1, you're left with 3x is greater than or equal to 7. Then divide by 3, x is greater than or equal to 7/3. So x is less than or equal to negative 3, or x is greater than or equal to 7/3. Now we graph it. So I need negative 3, I need 0, and 7/3. So negative 3 will have a closed dot, and you shade everything to the left. 7/3 will also have a closed dot, and you shade everything to the right. And last but not least, number 10, we have another absolute value inequality. First and foremost, is the box by itself? Yes, it is. So we can get started. This happens to be a less than situation. So the setup for less than, again, is if this is C, it's negative C less than your absolute value content, which is less than positive C. So that means it's negative 19 is less than 8h plus 1, which is less than 19. Okie doke. Alright, so now I must subtract 1 from all parts to get h by itself in the center, which would give me negative 20 is less than 8h, which is less than 18. I now will divide all parts by 8, which would give me a bunch of fractions that need reduction. So negative 28 is negative 5, sorry, 10 fourths. So, okay, go bigger. Sorry. So negative 5 halves, because they're both divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2, which is less than h, which is less than. Now over here, the only thing they have in common is that they're even. So you divide by 2. So 18 divided by 2 is 9. 8 divided by 2 is 4. So here's our solution. And now we draw our number line. We have negative 5 halves, we have 0, and we have 9 fourths. And then we have an open dot on both numbers because there's no equal to, and the variable is between, so we shade between. And this concludes the practice test, aka review. Good luck on your test next time.